factoring completely over the set of integers. We're going to factor completely. We're actually going to write the complete linear factorization of all of our functions. And we're going to do that so that we can find the zeros of the function. Or we might find the zeros and then go the other way. So 1 and 2, old news. We know how to factor these. This is pretty simple. If we're finding the zeros of the function, we want to know where the function has a value of 0. So what do we plug in for f of x? 0. And then we have 0 equals x squared minus 5x plus 6. So we would factor the right side. What does it factor to?
X would be x minus, wait, no, x.
X
minus 3, yeah.
X minus 3, X plus 2.
Very good. X minus 3 and X minus 2 are the factors.
Right.
Okay, because when we multiply negative 3 and negative 2, we get the positive 6. And when we add negative 3 and negative 2, we get the negative 5. Very good. So if we would distribute this back, it turns into that. All right, so if those are my factors, and I'm looking for the zeros, we first look at the first factor. What value of x would cause that first factor to equal 0? 3. And if the first factor equals 0, then the product would obviously be 0. So what value of x would make the second factor equal 0? 2. Now, this is old news because you did this last year. This was one of the ways you graphed a quadratic function. You found its zeros, which are the same as its x-intercepts. Oh. And then you knew the vertex was halfway in between, so halfway in between 3 and 2 would be 2.5. So you know the vertex lived right here at x equals 2.5. And then you knew it would open up. Remember all that?
That's a hyperbole. I mean, a
parabola.
Oh my God.
It's okay. All right, so you try number 2. Guys, and all you're going to do is this part. You don't have to graph it.
I did it.
We're about to tie every little piece together that we've learned. We're so close. We're knocking on the door.
Like a puzzle?
Yes. We can see the complete picture.
Sure.
And they'll be rejoicing.
Amen.
You had to say how long, like, the time writing on PSAT would last. How long did you say it?
For,
It's like 2.
2 hours?
for the timed writing for a PSAT?
No. Like what we have to do for qualification. If we
For what you have to do for AP Stat?
world history.
World History. Because you failed to sign up for PSAT. And it's really coming back to haunt you.
Yeah, it is.
I encouraged you, and you're
Well,
like, I'm
see,
good.
I was like, Zoe, do I need PSAT scores to get in? She's like, you should be fine.
Don't
Did
take
you
it.
take it? Yeah. Okay.
Don't take it. You're not taking it if you will.
But 2
You'll take it
hours.
later.
What'd you do?
I have absolutely no idea. I know AP Stat won't take that long.
Like trying to figure
Oh,
out how
the
to
exact
break
classification really easy to get. And accelerated last year. The week that we took the test was the week that we went over the potential again.
I thought you did like
Okay, so you looked at this and you thought, Miss Willoughby, you are so nice. Look at this, Miss Willoughby, you gave me a prime number. That's not even challenging.
Okay, I think I did good.
So you put a 3 there,
Okay.
and you put a 1 there, and then you're like, all right, 8, 2 factors, but no biggie. I got a 10 here, so let's go with that 4 and that 2, because 12, take away 2 is 10. Ooh, the 2 needs to be negative then, and that needs to be positive.
Okay, that's fine.
And you factored it.
I didn't.
Okay, so now you need to figure out what values of x would make this product equal 0. So if you can look at the first one and do it, fine. Some of you know that it's negative b over a. And so if you can't just look at it, set it equal to 0 and solve just like you did last year. So one of your factors is, one of your zeros
-4.
is 2/3, and the other you can just look at is -4. So those are my zeros. Now this form and this form, those are factored completely over the set of integers. They are also the complete linear factorization. Linear would tell me each of my x values is raised to what power?
1.
The first, yes. So we're going to look at two things for tonight's homework. Can you find all the zeros? Real and imaginary. And can you write the complete linear factorization? Which, these two, this line is it. But the rest of the ones we look at, when we factor it over the set of integers, that is not the same as the complete linear factorization. So, number 3, we would have to use one of our new types of factoring, which is that 4-term grouping. We would look at the first two and take out the x squared, and it leaves me x plus 1. We would look at the second two terms and we go, ooh, I need to do a -5, so then I'm left. That's not 1, that's a 2. That's an x plus 2. This is an x plus 2.
So you're
Okay, so this, my two factors are x plus 2 times x squared minus 5. Now, that is completely factored over the set of integers. But do you see where it's not the complete linear factorization?
Yeah.
Because this is a quadratic. So, the way we get to the complete linear factorization is we find the zeros. Well, this one's real easy. What would make the first factor 0? -2. But the second factor, you may need to do this. You may be able to look at it and tell. But you may need to do that. Because what do we do at this point? Take square root.
Oh my gosh.
And so, it's positive or negative square root of 5.
Alright,
So my other two zeros are irrational. Plus or minus root 5. So if I were to ask you to write the complete linear factorization, it would look something like this. X minus -2 makes it x plus 2. X minus positive root 5. And x minus negative root 5. What happens to minus and negative? So we would go back and take each of our zeros and just do x minus that 0, x minus that 0, x minus that 0. And that is the complete linear factorization. Because all my x's are to what power now? Yeah. All right, you try number 4. First, find your zeros, and then write the complete linear factorization.
Okay, back, Miss Williams.
Welcome back.
Jesus, you Bro, what is that?
so did you find that the zeros of the function occur where x has a value of -3 or positive or negative root 2?
Yeah, yes.
Okay, so my complete linear factorization would look like this.
Right, those connect.
Okay, so this one is our first one,
X 3,
and then,
X minus the square root of 2.
very good,
And then X plus the square root of 2.
there you go.
Yeah,
Alright, forget that. Got it.
Yeah, I'm recording. Okay, so that's our complete linear factorization along with our zeros. Yes.
On root, for example, why is it plus or minus root 5 when if you look at it, it's x squared minus 5? Don't we know that it's positive root 5? Because if you're trying to get it to equal 0, it
Well,
would be.
if I square positive root 5, or if I square negative root 5, I get 5. So they both work. Okay. All right, so this one is very similar, yet slightly different. So you go ahead and factor it, and let's see what you decide to do with it. See if you can find all the zeros.
No,
It's not that bad.
I love this class.
you're crazy with this question.
Why would you do this? It's beautiful. So these squares. X plus 4 than X.
Oh, no.
Oh, yeah.
I was doing something. Okay, I'm on the right page. Oh wait, I got it. I'm done. It actually wasn't that bad. It wasn't that bad.
You're done?
Because you could keep on the X plus 4. And then the X plus 2.
No, we can't do
No, it was the X plus 2, X plus. Keep it plus. And you got some. Never mind.
Why would you simplify that?
Julian!
Stupid! I'm sorry, I went too far.
You don't have to do that.
But isn't it up to
Honestly.
be negative?
Yes.
Yeah.
Oh, mine was negative 16. Mine's
Okay.
We did not. I got it.
Like, I seriously had it,
Don't wanna
and
hear
like,
it.
I lost it, like, right away.
Wait, do you have to keep going?
All right, so this line right here is completely factored in the set of integers. And then when we take the second factor, set it equal to 0 and solve, we end up taking the square root of negative 16, which is imaginary.
Oh, I can get it has to be negative for you to do this. Ah, it has to be subtraction. You can't do addition.
Right. Okay, so my other two zeros
Alright,
are
whatever.
imaginary.
It's whatever. It's whatever. It's whatever.
What does that mean?
It means they
And
cannot.
then in your head you're going, ooh, how will that affect the graph?
That's what I was thinking.
What's gonna happen?
They're not gonna show up.
It's not gonna.
Ooh, I can't wait to find out soon.
I'm with you.
Alright, so the complete linear factorization would look like this. X minus 1, X minus 4i, and X plus 4i.
See, I'm not gonna. We didn't add I. We just did
Can't
add
forget your I.
Oh, yeah, you're right. We had
Yeah, we just
it.
did
We
that.
had it right. We should have it.
We forgot to.
You take when you factor out a cube and you end up with a trinomial, but you have to complete the square in order to find zeros.
Nope, we're about to do one like that now.
Oh man, good job, bro.
Looks like this happy's ready to go.
Wait, no,
There's 7 more
I think
slots.
that's missing my question.
Huh?
This is what I was
Sounds
talking
like
about.
it.
Where is it?
What?
Oh.
Actually, I think it's my number 7. Are you trying to do your homework? It's my example 7 that answers your question.
Oh, that's number 7 on the homework.
Oh, interesting.
Well, what's it?
It's always a lucky number 7.
So did like
Alright,
every other person in stores.
And it's squeezed.
okay, so we'll take quadratic technique to factor this one.
What?
So this is going to factor to x squared and then plus 6 and x squared minus 3. So we're going to get some imaginaries with our first factor and some irrationals with our second factor. Mixing it up. That's all you can do. 6 doesn't break down, but the negative does. Alright, so this becomes this. And once again, most of you are going to get to the point where you don't have to show this work, because you just know. You know it. You just know it. So, my zeros. If I'm listing all of them, it would be plus or minus I root 6, and then plus or minus root 3. So we have 2 irrationals and 2 imaginaries. I bet some of you just go home and Google this to figure out how it affects the graph.
I am.
Oh, what is this?
All right, complete linear
Look up on your
factorization
phone, Julian.
would be x minus I root 6, x plus I root 6, x minus root 3, x plus root 3. And then there were 4 factors.
My breast is getting apples. Because I have this on.
So are you going to tell us those groups of
Is it just a...
Actually, you're going to discover that shortly.
I think I just...
No, we're not graphing today.
Is it... Wait.
Can't do it all. Can't do it all.
Wait, today?
Isn't
We
it
are not graphing
this will
today.
be? Isn't this like this? Do I have to zoom out even more?
All right, last one.
Come in. Oh.
Actually, it's an 8, but I don't think we do it. All right, so this is a 4-term factoring, and it's not highly exciting until you get right here and you pull out the x minus 2, and then you're like, yes, finally, been waiting on a perfect cube. Sum of cubes right there. That's what we've been waiting on. We haven't seen one of those yet.
I thought it'd be some factor.
Woo!
No, it can be...
Cubes can be a sum or a difference. Squares, only a difference.
Julian, seriously.
Okay, so, guys, this step right here is not completely factored over the set of integers, because this is a sum of cubes. So it factors to cubed root, square, product, square. Okay, so now we are completely factored over the set of integers. But it's not the complete linear factorization.
Yes.
I don't
And
like.
we don't see all the zeros.
There's two.
The zeros that we currently can see are 2 and negative 2.
Right. Yeah.
And guess what? This isn't going to factor.
It's not.
It disguises itself like you might want to think perfect square trinomial, but it won't work because the middle term messes it up. So, if you cannot factor, Hunter says use the quadratic formula.
Why?
Negative b, negative b, plus or minus square root, plus or minus square root, b squared minus 4ac, b squared minus 4ac.
That's what happens when I say something out loud.
All 2a. Alright. So, quadratic formula, negative b plus or minus square root of b squared minus 4ac
All over 2A.
all over 2a.
You're welcome.
Let's take it on.
No.
Alright, negative b becomes positive 2. Plus or minus the square root of negative 2 squared is obviously 4. Minus 4 times 1 times 4. All over 2 times. They're beautiful numbers. What are you talking about?
A little, Joe.
4 minus 16 is negative 12. Oh, it couldn't work until last week. But then our horizons were broadened. And we know that this is...
I squared.
Oh, yeah. Yes, it is. It's 2i root 3.
Why?
And then They're celebrating because 2 divides into everything.
So let's just wait. 1
So it's
plus
1 plus or minus I root 3.
That's what I thought.
1 plus or minus I root 3. So exciting.
That really
Makes you want to
was.
sing.
So they got 2
What?
From
Yeah,
negative 4.
do you remember?
Yes, yes. Because negative 12 breaks up into negative 4 times 3, and the square root of negative 4 is 2i, yes.
And then you
So
leave
it's
the
2i root 3. Alright, last step. Complete linear factorization. Here we go. Linear factorization. So, it's x minus the 2. X minus negative 2 makes x plus 2. X minus 1 plus I root 3. When I subtract all this, it becomes negative. X minus makes everything negative. And then the other one is x minus I root 3. Excuse me, I minus 1 minus I root 3 becomes x minus 1. But when we distribute the negative, it becomes plus
Oh, plus
I root 3. There it is. There she is. The complete linear factorization. And great
Physical
news.
pain.
The homework
Like, I have a headache now.
is the odds.
No, I'm not.
Oh, only the odds.
Odds.
Oh.
I'm gonna do the whole thing.
On purpose.
Yeah.
You did.
It says it right there.
It does say it right there, but.
I'm gonna do the whole thing.
See, I just love
Not for homework, though.
I don't blame you. It is
I like math so
fabulous.
much, I'm
See,
only.
Miss Lily, I'm so smart. I get all the evens first. Then I